Alright, this comes from these two lectures right here, ALU instructions and load and store. Here I've screenshotted a couple of things from that lecture that's going to be helpful, so that's just like something I'm going to use to explain. Here's our PC counter to load the instructions into main memory, and then it's +4 for the next instruction. You see how we have here, how it's just +4, it's 0, 4, 8, 12. It's like these are actually the binary equivalents, so like 0, 1, 0, 0 is 4, and then 0, 0, 0, 1, 0, 0, 0, this is 8. So these are actually straight conversions. These aren't random numbers. This is actually the memory address. So that's the +4, right? +4, +4, +4. And then, so we're going to go into the instruction memory right here. Then we're going to have things like our control logic, which is going to be responsible for, like, you see here in our ALU, this is the thing that's performing the math operations from for A and B. And we have things like the or the ALUFN, which comes from this control logic unit that comes down from our instructions. So see it's right here, so the output gets into this ALUFN right here, and then transports over here. The diagram doesn't show the entire circuitry, so it sort of is as an output, and this is the input. So we have our, let's do something normal, like, so we have our RA and our RB, as we see in our beta ISA, you know, this is usually our RA and our RB and RC. So it's usually, we get our A, and we perform the operation with RB and store in RC. So we have RA, perform the operation with RB, and store it in RC. And we go through here, I'm going to explain some other things. So this is our math unit, and this is our main memory unit. And let's go through, and then we have our RA right here, and our RB right here, so that loads it in. These are reading in this information, RA and RB. And then we have WD, which is telling us what to write into memory, like what are we storing to write into memory. So if I do A plus B right here, if I go through and I get A and B, it goes down to RD1 and RD2, and then that's going to go into the ALU unit, and it's going to say like A plus B. I'm going to go through, let's ignore this WD cell for a moment. It's going to go through, it's going to sit here at WD, so it's going to be like, okay, this is what I'm going to be writing into memory. But for us to even write that into, or well, write it into our register, but if we're going to write that into our register, this WRF thing, is going to have to be 1. WRF is telling us if we can write it into a register or not. So if it's 0, it's not going to write WD. If it's 1 right here, it's this 1, it's going to write it into our register. And how do we know where that's going to be written from? That's our RC. That's our RC. If you go back to the beta ISA, it's like that's this arrow right here. This arrow that's saying, okay, write that into RC. That's what this is right here, RC. So that's that WA is going to be telling us, okay, that's where we're going to be writing this into. That's where we're going to be writing this into. So, and then let's go over another thing right here. So we have this up here. So we explained this, what does this operate? Unsigned, yeah. We explained RA and RB for this thing. RA, operation regular, and RB. So that's this right here. But now let's go over what is this SXT. SXT is our literal. This is our literal right here. So if you go to the beta ISA, we can see the sext literal right here. Literal sort of means literally. Like if RA literally, I'm going to put 5. Like we have an example up here. I have like add C, where it's R1, which is like a register, like a variable in math. But we have 0, which is literally 0. It's like in math terms, a literal 0. It's not a variable. It's like a literal number that we're inputting. See, we have a 1 here. It's literally 1. It's not R1. It's not R0. It's not R2 or L or any variable. It's literally 1. And that could be in binary or in our decimal sense. So that's what this SXT means. It's literal. So whenever we're going to be using literals, we're going to be wanting to use this SXT. And to choose that SXT, instead of going through this RA and this RB, we have this B cell to choose that. And let's move on to our data memory, the MOE and the MWR. So this MOE is memory output enable, which tells us we want to read from main memory. We want to read from main memory. We're storing something into memory, and we're reading something from memory. We're either going to perform a calculation and have it stored in here, or we're going to have some state that's already existing in here and read it out. And this is the point of the WD cell, to choose whether or not are we reading from this math ALU or are we reading from main memory. And to load stuff into the data memory as well, we have this other path that comes off from our RB and stores it in our WD, and if MOE is 1, we're going to read stuff from memory, but if MWR is 1, we're going to be writing that into our data memory. So that's where we're going to be loading stuff into our memory. To show an example of this, that's this ST right here, which is memory. You see this memory part right here? That's how you know we're going to be using this memory unit right here. And then we have these SXT, so we know we're going to be using some sort of literal right here. And then SXT, so we know we're going to be using some sort of literal, and we know we're going to be using RA and RC. So this is RC, and RC is right here. So we're loading RC. See this? We're loading RC into memory, but memory is RA plus SXTC. So that means to get this RC to load into memory, we have this second path right here. See this RC, and that's when we're going to choose RA2 cell. That's when we're going to choose RA2 cell. So let's go through the examples right now. It might make a little bit more sense if we just go through it one by one. So we have add C. So we have add C right here. So let's look through. We have worth. Okay, worth is 1. So we know we're going to be writing something into our register. And we have WD cell is 1. So we know we're going to be reading something from the ALU. And MOE and MWR are 0, so we're not going to be using the data memory right now. We're not going to be using the data memory. So we know we have FLU, FN, and B cell. So let's look at this, add C. Let's look at the beta ISA, add C. Add C is under RA plus sext literal, so it's a literal. So now we know we're going to be using the C right here, which tells us our B cell has to be 1 in this case. So we're going to put 1 here, and our ALUFN, so we're going to be doing a plus as said by the beta SA, so we're going to be doing a plus operation. So we're going to have here that it is going to be A plus B. And what is our B cell? What did we say our B cell was 1? Where did that go? B cell is 1. Our B cell is 1. And that's the first row, and we have LD. So look at LD in our instructions. Where's LD? LD is here. Okay, we're going to be using a literal, and we're going to be using memory. So it looks like we're going to be using so we're going to be RA plus a sext literal is going to be stored in RC. It's going to be stored in RC. So let's look at some clues we have right now. We have worth. Worth is 1. So we know we're going to come back up here. Probably use the WD cell because we're going to want something to write into our registers. We have WD cell. So if we're going to be using, let me see, MOE is 1 right now. So that means we're probably going to be using this data memory unit right here. So that's telling us that, like, okay, since we're using the data memory right here, the hint we got provided by this MOE being 1, we're probably going to want this output to be 2 right here. So we're going to choose 2. And okay, so now that's done. Let's go to XOR. A XOR B. Let's go down to A XOR B. Let's see if we can find it right here. A XOR B. Okay, so XOR. So we have XOR. That is just RA, RB, and RC. So that's telling us that we're going to be wanting to use RA and RB, not our sext literal. We're not using our sext literal right here. So we're going to use RA and RB. So worth, we're probably going to, let's actually look at some other things first before we look at that. So we know we're going to use RA and RB. So that's going to tell us we're probably going to want to be taking this path, which tells us our B cell must be 0. So we're going to choose 0 here. So the WD cell, all right? So if we're going to be like performing this operation, chances are we're probably going to be wanting to read it from our ALU unit. And since our MOE and MWR are 0, this doubly tells us that we're not going to be choosing 2, that we're definitely going to be choosing 1 here from WD cell. So we're going to choose 1 here. And then A, X, or B, worth. Chances are if we're going to be performing this action, sending it to WD, chances are that it's going to be writing to our register on RC, because even in the instruction, we have this arrow. Let me erase it. It's kind of messy right now. We have this arrow here, which is telling us this operation is going to be sent to RC. So we're probably going to want to write that into our RC. So yeah, let me erase this. So you have the WA here. We have WA, so this is the address that we're going to write into, which is being held by RC. We have WD, which is holding the information that we're going to be storing. And then WE, which has to be 1, so we can write this WD into the memory that we're holding. So that's going to be telling us that that's 1. Now what is RA2 cell? Well, RA2 cell is choosing the C. And usually when we choose RC here, it's something like ST. It's something like ST, like, ooh, where is this? ST. Like we're loading something into memory and we use RC to do it. That's the only case where we use RC. So we're probably not using it here. So I'm going to put 0. So let's check these answers real quick. Okay, so we have A plus B, 1. We have the 1, we have the 2, and we have the 1, 0, 1, 1, 0, 1, and 0. And that's how you solve 19.